Howdy, I'm Jacob, and I'm joined by Ryan and Toby, and I would wager that some of the biggest crime scenes computing are on the HPC cluster. There's thousands of users on them that working on the same computational resources on various goals, and they may do things like trying to access root without permission, waste GPU and CPU resources, crypto mining, and just committing illegal activities in general using those resources. And going beyond the cluster too, there's computer systems installed by companies and government groups that may contain additional records of unwanted activity. And so we propose FileSnitch, a dashboard and tool that monitors file usage among HPC clusters and I guess computers in general to aid in digital forensics and identifying nefarious activity. And Toby, take it away.
Right on. So I'd love to walk you through some of the features our dashboard contains. Up here in the top left, we have our directory that shows all the users that are being currently tracked. If you want to click into one of those, it shows you all the files that that user has accessed, sorted by amount of time that they access them. You can see the same data of number of times a file's accessed down in our squarified tree mapping visualization down here. The bigger a square is, rectangle, the more times that file's accessed. It's sorted by the users. And if you click on one of those, then it'll show you the different processes and commands that access this file. So for example, here the user TS Cox, that's me, access this file with three different things, a couple of text editors and tail. You can see that same data through the top left directory. You click into one and click on a file, shows you the same stuff. One more thing, in the top right here, we have our terminal. If you want a little bit more detail, you can run some commands, for example, user, and that'll show you the details, all of the database entries related to that user. In that case, it's Ryan on the database. Speaking of that, I'll let him take it
Yeah,
away.
sure. So the database itself is basically done through running else off a bunch of times. And we query else off about about five, once every 5 seconds. And we do this in batches to sort of minimize the number of the seconds of overhead that we have running this program, especially for high performance computing sectors. We want to sort of minimize the number of extra resources we take. And as for the sort of front end and data, we send all the data to MongoDB, which is a cloud hosting service. And this keeps all of our data pretty secure and tight. As for the actual like design of the website, we built the website using Vue/Vite, and we deployed it to a Vercel instance, which further helps the security of our program. And to sort of demo this, we can actually talk about an example server over here, for instance. So let's run a server, for instance. And what this is basically a simulation of what would actually happen in an actual environment. And here I have a text editor pulled up to a C program running Vim. And if I were to go back to our instance and refresh the page, you could see that actually my instance over here is populated. If I click it, you can see actually this page over here, or this file, is running an instance of Vim, is being run by an instance of Vim, which is cool. And I'll actually let Jacob take away why this is important.
Yeah, this tool can be easily expanded across like different HPC cluster nodes and computers in general, and it offers pretty powerful heuristics for system admins and digital forensicists alike. For example, for system admins, I can quickly use this dashboard to find out what's going on with my users on the cluster. What kind of stuff are they accessing? Is it stuff that we really shouldn't be using these resources for, like honeypop, for example? And for digital forensicists, it also helps to maybe there's someone who committed a crime and they have a large record of using resources on HPC cluster and stuff like that. You have this dashboard and database that you can quickly figure out what exactly they're doing on there. And so that's kind of like the power of FileSnitch tool that we made. And thank you for listening.
Thank you.